Hi, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and welcome back to our lecture, Air Distribution System, and this is our third lecture. Alright, for this time, I will walk you through the system overview, all air handling unit or AHU, duct, control, and we will see several air distribution devices. Alright, let's look at the overview. An air distribution system, or ADS as in short form, it is a system that is used to deliver the conditioned forced air which carries heat and circulated in building space to achieve the thermal comfort. And the forced air is created by using external device such as blower or fan, and the forced air carries heat from a heat source, and it is introduced via supply ductwork. And we use register to supply the air, the conditioned air into the space via supply ductwork. Register. What are the difference between register and grills? Well, register is for supply ductwork, the outlet of supply air into the space, and grill is a return air. Grills is for return air, and it is installed in the return ductwork to remove the circulated air in the building space. Right, basically the form of register and grill is more or less the same. It's just a function that differentiates it. Alright, and the combination of forced air system with distribution system is called forced air distribution system. And normally, due to variation of velocity and air leaking, that creates that produces noise, and it also causes heat loss. This is common problems in ADS, and if the duct are not properly sealed or connected, then the problem become worse. So it has to be ensured that the connection between all branches in ductwork should be firmly sealed or insulated. Okay, this is the ductwork itself. And as you can see here, there are many parts of ductwork. We have supply grill, we have a flexible ducting, and flexible ducting is normally used for branches or at the end of the supply end. Alright, and we also have panel duct rectangular boots to connect the main trunk with the branches, and we also have panel duct round boot to connect main trunk, the rigid duct, rectangular rigid duct of a main trunk, with the flexible ducting, round flexible ducting. And here is a panel of the rectangular duct. We have transformation here, whereby the cross-sectional area of the duct becomes larger or smaller. So to change from one cross-sectional area to another, we use transformation or transition. Right, we also have elbows so that the airflow may flow into different direction. Right, so this is basically the parts of the ductwork. Okay, and whenever you design an air distribution system, you should follow airflow principles. And you have to select appropriate fan or suitable fan to provide the design flow rate, and it depends on more accurate calculation. You have to calculate static and dynamic pressure in the ductwork properly so that you may gain the duct size. And the ADS system use relatively large amounts of energy. Those, if you apply smart operational strategies, maybe use automatic dampers. For example, you use airflow sensor and so on. And if you do good maintenance practice, of course, this can significantly reduce the energy consumption. And two major organizations who oversee the certification process for the ADS system is ACMA and also SMACNA. ACMA is Air Movement and Control Association, and SMACNA is Sheet Metal and Air Conditioning Contractors National Association. Okay, this is schematic diagram for a space with installed ductwork, and as you can see here, we have supply ductwork, and we have register to channel the supply or the ready conditioned air, the supply air, into the space, and then it will go to return ductwork via grills, and this return air some will be released to the outside, and some will go to the mix damper to mix with the fresh incoming air before it is supplied again to the space after it is conditioned. Alright, and for heating system, we have furnace, we have blower to blow the hot air, the warm air into the space, and same goes into the space via register. Alright, so the cycles goes on. Okay, there are two types of air distribution system. First, we have constant volume, and the other one variable volume. And I believe this is just a recap. Constant volume, that means we just supply constant airflow rate into the space, and the temperature varies to maintain the zone set point, and it is used in single and also multi-zone. But as for variable volume, as the name goes, so certain volume are supplied into the space based on the demand of the set temperature of that particular space. And the variation is in response to terminal units intake of supply air to maintain the zone temperature set points. And we have normally automatic damper. And supply air fan is controlled to maintain a static pressure set point in the ductwork. So this system is also known as VAV, and the other one is CAV, constant air volume. VAV stands for variable air volume. Right, so this is the schematic figure for variable air volume. And as you can see here, we have, this is the outside damper, and the incoming fresh air go through filters, cooling coil, so that the pressure will be dropped to the suitable temperature to supply to the space. And this is heating coil to reheat the air if it is needed. And this is supply fan, and because it is after the cooling coil, it is known as drawn through fan. Draw through fan, and the air will be blown into the supply ducts, and basically this is the space. And just before the air enters the space, there's VAV box, or variable air volume. This is terminal unit whereby the damper can be is automatically adjusted so that only certain volume of airflow will be supplied to the space. If the space needs more cooling, then more volume or higher volume of airflow will come into the space. And if the room is already cold, so maybe the damper will shut off, and just after the temperature rise a bit, so the damper will open automatically just to supply the small volume that is needed by the space. Alright, and then the air, there is the heated air, the warm air will go to return ducts, and it comes back and drawn by variable speed return fan. And some of them will go to will be blown to the surrounding, and some of them will return and mix the mixing damper with the fresh incoming air before it goes back to the AHU, or air handler unit. Alright, are you on the same page with me? Alright, so this is basically the same figure. It's just that here there's label here, and here you can see more clearly we have damper here. This is the damper motor to open or to shut the damper. And of course, if it is automatic, we should have sensors. We must have sensors. Alright, and this is control, and to see the cooling coil temperature, whether it is meet the requirement or the set temperature. This is control for the fan, to control the speed of the fan. And of course, there's a pressure sensor that is placed in the airstream, so that we can monitor the pressure in the duct. And if the pressure is low, then the fan speed will be hired. Alright, so let's talk about air handler unit or air handling unit. It is actually an integrated piece. It consists of blower or fan. We have heating and cooling coils, we have control, we have dampers, we have filters, we have silencers, so that to insulate the sound that is caused or noise that is caused by the air velocity, and also we have vibration isolator. And the purpose of AHU is to collect back the mixed outdoor air with the return air from the building space, and then it will be reconditioned. It will be filtered, cooled or heated after which it is discharged into the building space through a duct system. And basically AHU often made of metal box, and this metal box size is according to the component size, and the components will be placed in the metal box. And arrangement for several equipments that make up the AHU is the most important, and it depends on the purpose of use. And the size of AHU depends on the number of equipment size, and we have to see what application it is for, and therefore it is recommended to provide a schematic drawing or use any software to illustrate the proper design so that we know the actual size of the AHU after we choose all the components. Alright, and type of AHU. We have based on size. We have terminal units, we have normal AHU, and we have large AHU. And a larger air handler unit is normally designed for outdoor use, and typically we place this larger AHU on roofs, and this is also known as package unit or rooftop unit, RTU. And we also have small AHU, which is known as terminal units. Although it is small, it also has air filter, cooling coils, heating coil, and also fan. And normally it is used for local use. And a larger air handler that conditions 100% of outside air and there is no return air is known as makeup air unit, or known as MAU in short form. Okay, and type of AHU can also be classified based on fan location, and we may have draw through unit, whereby the fan is located after the coil, after the cooling and also the heating coil, and the fan will draw the air into it before it blows into the supply duct. And the other one is blow through unit, and the fan is located before the cooling coil so that the fan will blow through the coil. Right, next component, Just now we talk about fan. Now we look at duct. So this is part of ADS, air distribution system. And basically duct is a channel to deliver and remove air from a building space. And it can be categorized into several types according to materials used, such as galvanized mild steel. We have PU, polyurethane, phenolic insulation panels. We have fiberglass ductboard. We have flexible ducting, which is normally round in shape, and we also have fabric ducting. It depends on the use. Alright, and a duct system is often called ductwork, and planning or laying out, sizing, optimizing and detailing and finding the pressure losses through a duct system are called duct design. So basically, if you design a duct system or air distribution system, you have to really plan from AHU into the last of involved space. How long is the duct? How big is the duct based on the needed CFM of the particular space, and from there you will know the size of the duct that is needed for that particular design. And of course there are several methods, and we'll be explaining in later lecture that you can use to design a proper air distribution system. And duct may originate in round or rectangular shape, and the ratio between the width and the height is preferred to be as small as possible. So 1 to 1. So basically the best shape or the best ratio is 1 to 1. That means the best shape is square for a duct. Okay, so how to convert from rectangular duct to circular duct, or the other way around? So the equivalent diameter is the diameter of a circular duct or pipe that gives the same pressure loss as the equivalent rectangular duct or pipe. And we will be using this formula to convert from round duct. If we have a round duct with certain diameter, and we may or maybe we have, I'm sorry, the other way around. If we have width and height of a rectangular duct, we may calculate the diameter, the equivalent diameter of a round duct. That will give the same pressure loss. And the formula is DE, or the equivalent diameter of the round duct, is equals to 1.3 times AB to the power of 0.625 over, or divided by, A plus B to the power of 0.25. So if you have this one, you may calculate the equivalent diameter of a round duct. Alright, now let's look at an example. So what is the size of rectangular duct if the equivalent diameter of circular duct is 8 inch? Alright, so this is from rectangular, this is from circular duct to rectangular shaped duct. And since we have we just have only one equation, but we need to solve two variables, so it is impossible to use the formula that we have just explained about. So what you can do is actually to calculate the area of the circular duct by using the formula pi r squared, and you will get 50.24 inch square. Then you just find an appropriate size by multiplying two values, width times the height. Of course, the best is 1 to 1, but if there's no nearest value that we can get, we can also use width times height with a ratio 2 to 1. Alright, before we proceed to control, I want you to bear in mind there are several rules that you have to remember. There are three rules in air distribution system design that you have to always remember. The first rule is there is no odd number for duct size. There is no 11 inch, for example, duct size. There is only the only odd number that for duct size is 3. We have 3 inch, but other than 3 inch we don't have any odd number for duct size. We have 4 inch, 6 inch, 8 inch, and so on. And just bear in mind, if you have to choose between two sizes, you should know that when you oversize, then the friction loss will increase, and if you undersize, the friction loss will decrease. If friction loss, if the diameter is higher, the price, the duct price is also higher. Alright, and you have to know the round duct is more pricey than the rectangular duct. And rule number 2, the first one, no odd size, no odd number for duct size. Rule number 2, the best ratio between the width and the height of the duct, of a rectangular duct, is 1 to 1. And rule number 3, the ratio of width to the height of a duct shouldn't be exceeded 1 to 3. The ratio 1 to 3. That is the rule number 3. And you also have to know that the flexible duct length, the maximum flexible duct length is 3 meter. So just take note somewhere. It is very important for the design, for the duct design, for duct layout design. Alright, let's now look at the control of ADS. And control is needed to regulate the airflow rate in air handling unit, supply air temperature, mixed air temperature, humidity, and also the air quality. And control may be as simple as off and on thermostat, or as complex as a building automation system. For example, we have BMS, building management system. Alright, and common control component includes temperature sensors, humidity sensors, sails, switches, actuators, and also motors. So control and sensors cannot be separated. This is our next ADS component. We have blower or fan, or known as fan, and like we have introduced in the previous slide, we have draw through fan, and we also have draw through fan, and also the other one is blow through fan. Right, so it depending on the location of the fan, either it is before or after the coil in AHU. Alright, and next component is heating or cooling elements. These are elements in the AHU. So we know that AHU is also a part of ADS. Therefore, it is also a component of ADS. So I'm not gonna talk much about heating or cooling elements. I believe all of you by now already know what is heating or cooling elements. But just to recap, it is located after the filter in an AHU, and after or before the heating or cooling elements, there is a fan, or fan, which is placed to draw or to blow the supply air. And if the condensate drain line is under negative pressure, that means it will flow, the water, the drain water will flow back to the coil. So to avoid this, we can use trap. We use trap in condensate line, so that there is no flow back of the drain water, of the condensate water. All right. Okay, here you can see the evaporator coil, and this is just before the compressor. All right. Okay, next is supply duct and return duct for main and branches, right? And this is the main trunk or main branch, and this is the branches. And normally for branches we use flexible duct, but just to recap, not more than 3 meter length. And for main trunk, normally we use rectangular duct, rigid rectangular duct. And this is typical trunk and branch duct system. This is two-way system, and the other one here is one-way, typical trunk and branch duct system. Why one way? Because AHU is at the end of the system of the ductwork, and the other one, the AHU is in the middle, and the supply air goes to the left and also to the right. That is why it is called two-way system. Right, last but not least, we have diffuser and grills. And as you can see here, there are many forms of diffusers and grill, depending on what type of air pattern that you would want to experience. For example, here we have four-way airflow. We have diffusers with four-way structure. The airflow will go in four different direction. For example, we also have circular diffuser. It goes in circular way, so like this, in all direction. And sometimes we can see there's grills like this, only one direction outlet. And this one is four-way direction airflow. Yeah, it depending on the design, it depending on the necessity of that particular space. For example, if you are in a office whereby there are many staff that in that particular space, so you will need a diffuser with different direction outlet. Alright, I think that is all for this time, so see you soon in next lecture. Thank you. Assalamu alaikum.